directions. Excuse me. Alright, so right shore edge will take the magnitude of that value. So what are we going to do with that? We're going to detect the shore. So we've got our 4 in32i equals, or x equals 0. X is less than mmap.m width plus x. Let's just do it naively because we can. Plus y and 32 index equals x plus mmap.m width times y. So f vector 4 so our distance data is the R channel. Alright, so what we're going to do is we could go ahead and write a 0 in here. Like what we do is we would write the shore value if it's 0, and then we could blur it in or something like that, but we need the inverse direction, so we can't just write zeros. We need to actually write everything out. Let's see, what's our int32 edge radius is something else we'll need. Radius of 10, maybe? Radius of 5? Let's just do 5. So 4 int32 inner x equals negative edge radius. Inner x is less than or equal to edge radius plus inner x. There's gonna be a lot of normalization. There's a lot of square root calculations in this thing. This is gonna be slow. Well, it's just gonna be slow then. Alright. Alright, so AX is going to be x plus inner x, and 32AY equals y plus inner y. If AX is less than 0, or AY is less than 0, or AX is greater than or equal to mmap.width for AY is greater than or equal to map.height. Continue. Alright, so what we're going to say is if the pixel that we are, if distance data sub index dot r is greater than 0, I guess we'll just say if it's equal to 0, continue. Alright, so if dist.r if dist.x equals 0 does not equal 0, continue. So distance data.x this would be the calculations after pre-processing information. Alright, so what we're going to do is we're going to write the direction to the location that we are at. I mean, we need to add it all together, don't we? That's inner index. I'm trying to think about how this will work. So as we're iterating over all these pixels, we're going to be encountering water pixels, and we're going to be wanting to write the direction in there. Are we going to average the direction that's already there and just set the magnitude? How would that work? If something was surrounded and we averaged everything, the directions would point just to nothing. But if we normalized it after we did this, and we could add them together and divide by 2. So we need the normalized direction that we currently have, add that with the current direction, and set it. But if it's set to 0 to start with, we're only going to get half of the direction. So we need to not normalize the direction? Or is the magnitude going to be the thing we need to add in? How do we blur this? It's if we have the direction and the magnitude. Well, the direction would always be something. But theoretically, we'd want it to be able to cancel out and do nothing. I guess if we normalized it and then we did that, then we'd know exactly what the values are as like they're less than 0. Alright, so if the, we're going to have f vector 4 pix equals this thing. So if the x is 0, continue. Alright, so if pix dot size squared equals 0, then we're just going to set it. Otherwise, we're going to average it and set the magnitude. So pix dot w equals mag. Should be mag divided by distance? Or should we do like adding together everything here? Yeah, this is more complicated than I was thinking it would be. Because we can't just take a running average. Like if we added it all up, we would need to keep track of lots of stuff. So I actually need like an entirely separate data structure than a vector 4 for this. Because I'm trying to think about all the different, how the numbers are going to come together. Like if we incrementally add all these variables together and all this other stuff, what's it going to look like? What are the numbers actually going to do? Because we could write how many we wrote to it and just add it all up and then divide. But we can't really do that with a vector. We need a different data structure. What we actually do is we need like a struct calculated flow pixel. And what we're going to need is like float x, float y, and 32 writes. We're going to need like a bool, if it's a path node or not. We need a bool for like if it's a pixel, a particle. So we'd have to do for, I believe, this short edge stuff. So we also need this T-array of calculated flow pixels here, which is going to be pixels. We have to do pixels.init. Let's look up T-array real quick. So I'm going to need to pass this to array in here. Alright, so the magnitude is going to be the... We need to take the current value. So like if pix dot right equals 0, then we just set it. Otherwise, we're going to do stuff with it. Alright, so a little bit more crazy, ridiculous than I was thinking we would be just for like blurring a shoreline, but it's not as simple as you might expect. So we're going to have our AMAG is going to be the magnitude divided by the edge radius, so it's going to be, we're going to need inner x times inner x plus inner y times inner y. This will be the magnitude squared. So the mag is going to be the edge radius times edge radius. Yeah, we'll divide this out here, and then the magnitude that we're actually going to write in here. Alright, so we multiply those out, and then we're going to multiply that, because that's going to go from 0 to 1. We're going to need to do like 1.0f minus that, and then we're going to have to multiply that by mag. So that's going to go from 1 to 0 with an exponential fall off. I believe an exponential fall off. And then what we need to do is we'll take our dir, which is going to be I guess it's just inner x, and dir.normalize, and we're going to say dir times equal this mag here. Let me just write that into it. So pix dot x equals dir dot x and pix dot y equals dir dot y. Otherwise we add it. So I guess it's just always plus equals. So that'll have a repulsion magnitude. Things get more repulsed the more shore pixels are that they're next to. But the magnitude is not going to be a maximum magnitude. It's just going to be like a how. Yeah, it's okay. It's not great, but it should work. At least we're not doing too many square roots, right? Just a bajillion of them. Well, let's see how that looks. So, step 7, convert to world space, and step 8 should be write to data. I guess normalize and convert to world space. Alright, so for every pixel here, in pixels, let's see. Get world position for grid? I guess it's X step and Y step are axes or something like that. So it's going to be yeah. So we need the basis vector. X basis equals mx step. F vector y basis equals my step. We need to do x basis dot normalize and y basis dot normalize. And our directions are going to be our pix x times x step plus this. These are normalized vectors, so we add them together. Are they going to be still normalized? They're going to be orthogonal to each other. So I believe so. Alright, Chris Goku, you talking about the Unreal build stuff? Or, because yeah, Unreal's got a whole bunch of C# tools. Otherwise, I'm not really sure what you're referring to. So this will be our direction. And we're going to write the magnitude to something else. Our x and y, we're going to need to divide by the number of rights. Is that true? At this point, I believe we will already have them normalized. So we're going to have to go through and normalize stuff. So let's just do a normalized pass up here. The dynamically loaded modules and stuff. Yeah, the like we actually wrote 2 plugins earlier today. But yeah, all these like modules that you load in and stuff like that, dependencies. The Unreal build tool generates the project files and does all that shenaniganry for you and all that. Yeah, if you want to look at the source for that, it's all inside of the Unreal header tool and Unreal build tool down there. It's, I don't know, not super interesting in my mind. I guess I should just use an F-Vector 2D here. Just because I should. Alright. Let's just do our pause and all that stuff. I guess this will be the X and the Y here. Speed.x and xstep.y. This will be y step. Are these normalized? They're normalized. I think that'll remain the same length. This will be x basis and y basis. Alright, so we'll normalize everything. Alright, so we'll get the direction vector, which we actually need to write into this texture thing. And for pix and pixels. I gotta use 32, I equals 0, I is less than 32 size equals pixels.num. Pixels I. Alright, so we're going to need the actual flow field data sub I and the sub I here. So we need the f vector 4 reference back. I'll call it dat, and f color. So we're going to say dat.x equals dir.x, dat.y equals dir.y, dat.z equals 0. We're not going to care about flowing down hills. Do we care? Do we want it? Do we want that sort of stuff? I mean, if we had water that was flowing downhill, yeah, I guess we do. Guess we do. So how in the hell do we calculate this? I guess it's pos.x and then pos.y. So that'll be our basis vectors. Okay, that makes sense. Alright. And this will be an f vector. So this will be dir.z. And dat.w is going to be the pix.mag. Alright, so the actual flow field is going to be, this is going to be the direction. We're going to go from like, God, it's going to be real hard to actually imagine. It's going to be hard to draw properly. So I guess we're going to have to go from 0 to 127 equals, I guess, -1 to 0. 127 to 255 is going to be 0 to 1. What would be the greatest magnitude there for the A? I guess we need a max magnitude. That's it's going to be like this, multiplied by 255. So TTT So that'll fix that error. Alright. Okay, so these directions are going to be from -1 to 1. So if we multiply them, if we add 1, it goes from 0 to 2. And then if we multiply by 0 to 2, alright, if we so color.r equals dat.x plus 1.0. So we go from 0 to 2, and then we multiply that by 127. I guess 128. So that's going to go from 0 to 256. And then we are going to round that. We're going to subtract 1 from it. We're going to subtract 128 from it. So that should take us from 0 to 256. You round it to an integer. So at 0 to 256 we add it. It's going to be from no, this is incorrect. We want to do 128 plus from 0 to 1. It's going to be 128 plus 127. Multiplied by, yeah, well, fmath, what, round to int. 127 multiplied by dat.x. So it's going to be from -1 to 1, and then we'll just add it. It'll go from 0 to 255. Yeah, so simpler than I was thinking. God damn it, autocomplete, get out of my way. Alright, so those are normalized and converted. Alright, well let's compile that and we'll go view it and see what it actually looks like. So let's run it and see what we got. Alright, so we got generate flow field, which will save the real flow field data and everything like that. So construct the static data, and we'll call generate flow field. Our map should be created. Oh god, I hit the frickin' init button. Well, that's just an upsetting bug with Visual Studio and the generics and some of this stuff where, because it's actually doing this init function, you can't step over it because it'll just lock up the debugger forever. Yeah, Chris Koku, if you're looking at including the online subsystem module, yeah, then it's all in that C# stuff. And then you'll be able to, like, you know, actually include the header files and reference everything. Alright, so let's see. The direction is X basis and Y basis. Actual flow field data for XYZ mag. Like, I can see it in here and it looks correct. I just want to see it in the world. Actual flow field texture is in there. Let's see if we're actually setting it in the blueprint. You should learn C++, C# and .NET. I don't know. Those build system things aren't super valuable in terms of if you're doing the game dev stuff. C# I would not learn because of a build system. I'd learn C# because C# is a decent language to program games in. But the build system is really about just reading the documentation. Not really anything else. Alright, this is setting text to actual flow field. Let's make sure this thing actually gets hit. We're not setting it. Why not? Test actual flow field is toggle viewing the actual flow field texture. Which one is getting called then? So distance map works. Ah, yeah, that's because I've got this giant ore thing in the front here. Alright, so what are the vectors going to be here? What do these represent? It looks like the correct directions, like this direction and this direction. Like everything on that side is blue, everything on this side is red. You know, like you can see the vectors actually looking proper. And that's what we expect for all the shore values. And that's 10 pixels for a calculation. It looks like we might need a little bit more than 10 pixels. Oh, let's up it then. And this is going to look kind of like a normal map. Well, if you look at how everything is built, let me see if this will actually cooperate. So if you look at what's built with your binaries for this thing, so when you actually build your object for your program, you've got your Dashkin DLL and everything like that. That's finally made, and let's see. I think it's like yeah, your binaries that are built for all your stuff are actually these DLLs that are loaded up here. So like these are all plugins. These are all modules that get loaded in. So yeah, when you mean dynamic, it's gonna actually grab the DLLs if they're dynamic loaded and all that. But we've also got this Dashkin extensions runtime lib that gets created. So you've got DLLs and you've got libs. And I'm not sure which one is used in the final build, because you can actually look at, like if I've got the test build here, the test build binary has got a single executable here. And if we look in here for like star.dll, there are DLLs, but all these are like third-party DLLs. So it's pretty clear that when you're in like the editor and stuff like that, I think it's loading DLLs for everything, and I think when you're actually running like a standalone build, it's building the executable with a bunch of libs. So I think that's kind of how it works, and that allows like hot code reloading stuff inside of the editor, so that you can change your C++ code, hit the compile button up here, and it'll actually recompile your plugin, which would be your code, because your code's actually just a DLL that's running inside the editor, and the editor can swap those out and all that. At least that's my guess. I don't know exactly how it works. I just have a theory. Alright, let's change the shore radius to like 10. See how that looks. Yeah, C# is actually a pretty good language to learn right now. because I think what that whole Windows initiative, where they're going to get C# running on things that are not Windows machines and all that, I'm pretty sure like they're going to get it running on Mac and everything. I forget exactly the details and timeline for that, but it seems like C# is going to definitely have a large uptick in supported platforms very shortly. Well, there's a big difference between C# and Java, and that C# allows you a lot more native code access. You can do the same thing in Java, but it's kind of a lot messier language. It's kind of the wrong tool for running client programs, I think, in a lot of ways. Like Java's much more a server language. Interesting. Alright, so we do have a problem here, which is these areas are not going to get treated correctly because they're garbage. And why aren't these textures white? They should be zeros. Why are they not zeros? Alright, so we need a way to fill these things out. So how would we fill them out? We could just have a repulsion on everything. Just be like, it always runs. So even if it's a 0, it gets written to. Well, let's try it. Let's try writing even if we're 0. Let's actually not skip this. Pix x equals 0. Let's just see what it does. Yeah, Unreal's actually got a pretty decent build system, like for how it's all structured together. So it's kind of cool how it works. Like for how complex it can be, it's a lot better than it could be. There's a lot of boilerplate for setting up your own modules and stuff like that, but it's at least consistent in how much garbage you gotta wade through in order to actually get it set up. They don't have like a whole bunch of gotchas everywhere with like, oh, well, you forgot the magical blah. It's like, well, you forgot the magical blah. You always need the magical blah, so just have the magical blah. It's not like, well, this is a special kind of editor module, so it needs this other thing inside of it. It's like, no, they all need the same magical incantation to actually work properly, which is just fine with me. The green is to the right, or the green is what? What the fuck is this green? It's like the magnitude isn't getting set properly. The magnitude is the inner x multiplied by the inner x 1.0f minus it. This is the distance divided by the edge radius. What is totally blue? Probably trash. Well, what I need to do is I need something else for this. This is incorrect. Like, it's correct in what we have right now with ignore the pixel, but I need to fill in the edges. I need to like expand this stuff after it's finished outwards. So God, that's complicated. No, okay. We need this sort of thing, but I guess maybe the actual magnitude we should just write. And let's just try that. We'll just try mag. And see how it is. The other thing we could do is we could take the opposite tack of trying to move away from shore as opposed to having shore repulse. We could have the other pixels find the shore and then move away from it. But I think this might work. I think it's just the magnitude's wrong on some of these, so... Yeah, that's looking more like what I would have expected this to look like.